Hi everyone, and welcome to the Job-A-Thon analysis. Let us discuss the very first problem, that is optimize array cleanup. So let's understand the problem statement and see how we can solve it. Problem says that Geek has been given an integer array which is of size n. So total n integers are given by his teacher, and his task is to make the array empty. So finally you want to do what? You want to make the array empty by performing certain kind of special operations. So in every operation, Geek can select a subsequence from the array. So basically he can select certain elements from the array, and he has to select the subsequence in such a way that all the elements in that chosen subsequence are distinct, and he has to tell that minimum how many times he has to perform this special operation. For example, suppose if the array is what, let's say if my array is 1, then I have got 2, then I have got 3, and then after that I have got what, let's say I've got 1 comma 2 as well. So if I have got this particular array with me, then what we can do is, in the first move, if we take the element 1, 2 and 3, so all these like in this sequence, in the first sequence, if I do what, in the first subsequence, if I take 1 2 3, so you can see that all the elements that I have chosen currently are distinct, and then I can remove it. So that will be one step, right? This will take one step, or you can say one move. So indirectly 1 2 and 3 will get removed. Then after that, what I can do is, in the next step, if I want, so I can choose 1 and then 2, so I can choose this particular subsequence. And if I choose 1 and 2, so both the elements are distinct, right? Then this will take another step, and in the second step, you can see that after the second step, so if I remove these two elements as well in the second step, then you can see total in two steps the whole array becomes empty. So I'm able to achieve my target. I'm able to optimally clean up this array, right? So I took two steps. So what is the scenario, like how can we solve this problem, right? What will be the worst case scenario? So let's assume another array. Suppose that if we have got what, let's say we have got 7, then we have got 4, then we have got 4, then we have got 7, then we have got 7, then after that we have got 4, then we have got 3, and then we have got 2, and then we have got let's say 3 again. Okay, suppose if we have got this particular array, right? If you take out the frequency of the elements, so the element 7 is going to occur how many times? 7 is occurring, let me write 7 one more time. So let's say 7 is occurring here as well. So total number of times that the element 7 is occurring is how much? 1 2 3 and 4. So 7 is occurring 4 times. Okay, then if you see 4 is occurring how many times? 3 times, right? Then after that the element 3 is occurring 2 times, and the element 2 is occurring 1 time only, right? So basically this is what I've written, element and the frequency of the element. Okay, so if you will see here, first time what I can do is, if I choose 7 then 4 and then 3 and then 2, so what I'll do is, if I choose like one element each, then you can say that 7's frequency will become 3, then 4's frequency will become 2, 3's frequency will become 1, and 2's frequency will become 0. So basically I've chosen one occurrence of every element. So 1 times 7, then 4, then what, then 3 and then 2. So this is what I've done in the first step, right? Now in the second step, what I can do is, let's say if I choose the element 7, okay, then I choose 4. So if I choose what, like you can say 4 7, right? Then after that I choose 3. Okay, so you can see that if I, because now 2 is no longer available, so if I choose 4 7 uh, 4 7 and 3, then in the second move, after the second move, frequency of all the elements will decrease by 1. So then you can see that 4 7 and 3 will get removed. Then again in the next move, what's going to happen? So in the next move, I will basically choose 7 and then 4. So in the third move, I'll choose 7 and 4, and I'll decrease the frequency by 1 each. So then you can see that 7's frequency will become 1 and 4's frequency will become 0. Then after this, you can see 7 is still occurring, right? So in the last step, I have to choose 7 one more time, right? And then you can see that basically in 4 moves, I'll be able to clean up the array optimally, right? Because in every step, I have to choose only distinct element as subsequences, right? So you can see here that I took the maximum number of moves as how much? 4. So if you'll see, the final answer is basically the frequency of the maximum occurring element of the array, because whichever element occurs the maximum number of times, so we have to always keep it one time each in every subsequence, and by doing that we'll be able to clean up the array. So finally you can conclude that the maximum time taken, or the number of steps that I'll take for choosing subsequence in such a way that every time I'm choosing distinct elements in any subsequence, so the final time taken will be the maximum frequency of the element. So maximum occurring element will take the maximum time to get removed from the array, because in every subsequence I'll be choosing it one time only. So let's implement this code as well and see how we can get this accepted. So what I'll do is I'll first of all declare an unordered map. So let's declare a map here, and it will be integer comma integer, because for every integer element I'll store the frequency, right? Then after this, what I'm going to do here is I'm going to iterate. So I'll say that int I starts from 0, I is lesser than let's say n, then I'll do I plus plus, and then after this, also one more thing is that I can keep one answer array, answer variable, which will help me to keep the track of the maximum frequency element. Okay, so I'll say that whenever an element is coming, so I'll increase the frequency of the ith element. Okay, and then I'll check that if the frequency, if this particular element that I am at, if its frequency is greater than the maximum frequency that I have stored, so in that case my answer will be updated with this particular frequency. Okay, and once this part is done, then we can simply return the maximum frequency, that will be the number of steps maximum taken by us. So let's return this answer, and let's try and submit this to check if it is getting accepted or not. It should get accepted. So yes, it says that I have made some mistakes. Yeah, colon was missing in line number 37. Now let's compile it again. Okay, right now it's getting compiled. Okay, it works fine on compilation. Let's try and submit this code. It should get accepted. Let's see. So you can clearly observe that our code was able to pass all the test cases. The time complexity for this approach will be order of n, because we are iterating throughout the array, and the space complexity will also be order of n. I hope you have understood this problem. So let's move on to the next problem as well. Let us discuss the next problem, that is distinct array optimization. So let's read the problem statement. Let's understand what it says, and then we'll solve it. So it says that Geek received an array of size n. So basically there are n integers, and his teacher wants to make all the elements of the array distinct by using two kind of operations. So what you can do is either you can remove the first element of the array and place any element of your choice at the last position, or what you can do is in one move you can remove the last element of the array and place any element at the beginning of the array, right? And you have to basically tell that what is the minimum number of operations that you can have. Now for solving this kind of problem, what I can always say here is that suppose that if I will be given an like any array, so let's say if the array that I have looks something like let's say this. Let's say if I've got 1, then I've got 5, then I've got 3, then let's say I've got certain array here. Let's say I've got this, then I've got 4, then I've got 6. Okay, then after that we have got 3, then we have got 3, and then we have got 3. So let us assume that we have got this particular array here. Now in this particular scenario, if you'll observe, so I want to minimize the number of operations that I'll be performing, right? I want to minimize the number of changes that I'll be doing. So what is the largest chunk of the array in which I don't have to change? So for that, what can I do? I can basically apply the sliding window concept first of all, and I can maintain a range L to R in which I'll be always having the distinct element. So suppose that in this case, if you'll observe, so from this range, I can say that in this range, let me change the element. So let's say I've got 6 here. So I can say that in this range L to R that I have, all the elements are distinct. Okay, from here till this point, all the elements that are there, they are distinct. For example, 5, 3, 4, and 6, all these elements are distinct. So I can always maintain a window from L to R which will always be consisting of the distinct elements. And now I would like to change which kind of elements? I would like to change the elements on the left side and the right side of L and R. On the left side of L, I would like to change the elements, and I would like to change the elements on the right side of R as well. Okay, so if you will see here, what I could have done is if I always maintain a window, then after that what I could have done is I could have taken on the left side, how many elements are there? On the left side there is only one element. So if I do what, if I take this particular element and then I place it here, place any other element here. So let's say if I place any other element, let's say I place what, let's say I place 77 here, right? Then does the array become distinct? Does do all the elements become distinct? No, they don't become distinct, right? So then I can say that all these elements that are there, I need to again place them in the front. Okay, I need to take them one by one from the back side. I want to take 77, then 3, then 3, and then again 3, and I want to place them in the starting in form of some other element. So basically what you can understand here is that after I have got a L to R range in which I'm having the unique elements, then after that what I need to do is either I have a choice to move L elements from the starting, okay, because I have got L elements. So what I can do is I can move L elements from the starting towards the end, and then after that, even then these elements are not distinct. So again I will pick up these elements, these whole elements from the back side, and I'll put them in the front one by one by changing. So if you'll see here, L elements, first of all I have transferred from the starting to the end one by one. Okay, that operation has been done. Now I would like to do what I am saying, that I will take all the elements from the back side to the front side. So already how many elements were there on the back side? The already elements were n minus 1 minus r plus L elements more were there. So from the right side, these many elements I'll put again in the starting one by one, right? So total L elements first of all migrated to the right side. Okay, then after that, total number of elements that are there on the right side of on the right side that are kind of not distinct, I will take them one by one from the end, and I'll place them in the beginning by making them into some other element. So that operation will take how much time? So n minus L minus n minus 1 minus r, because these elements are already there on the right that I have to shift, okay, plus the L elements that I have taken from the left side as well. So total this operation will take 2 into L plus n minus 1 minus r. Or what can I do? Other thing that I could have done is that if I have this window L to R, okay, so what I can do is all the elements that are there on the right side, okay, all the elements that are there on the right of R, first of all I can place them on the left. So that will take how much time? That would take n minus 1 minus r amount of time. Okay, then after that all the elements that are there, still what might happen is, still after performing that operation, the elements might not be distinct. So I have to take all the elements from the left to the right again. Okay, so all the elements that were already existing on the left of L, those elements along with the elements that I have shifted as well. So plus L plus what? N minus 1 minus r element. I'll change them and I'll put them at the back one by one, okay, by taking them from the front. So here the total number of operations that I would have to perform is what? L plus 2 into n minus 1 minus r. Okay, so these are the operations that I can perform. Basically, if I have a certain window from L to R which has got distinct elements, then what I can do is all the elements that are there on the left, first of all I can transfer all of them on the right side. Okay, let me write this scenario again. So if you have got this range L to R, and now on the left side, like I have got certain elements on the left and certain elements on the right. So maybe what I can do is I can take all the elements from the left and I can put them on the right side, but still the sequence might not be distinct, because suppose if I've got 9 here in between, and here I've got 999 suppose, and then I've got some other elements that I transferred from the left. So still the whole array doesn't become distinct. So that is why what I have to do is I have to pick these guys up and I have to place them in the starting of this array, right? So first of all L operation for placing all the elements from the front to the back one by one. Then after that n minus 1 minus r operation for putting the like putting the original elements that were on the right side to the front, and plus L operation more for whatever elements I had transferred on the left, I am again putting them on the right side by changing them. So basically this will be total 2 into L plus n minus 1 minus r. Now same thing can happen on the right side as well. So if you have got a range, as I said, from L to R, and first of all the elements that are there on the right, if you place them on the left side first of all, so that will take how much operation? N minus 1 minus r operation, plus now whatever total elements you have got on the left side, still they might not be unique, because suppose that you have got 9 here and you have got certain 9 elements here, and then you whatever elements you transfer, so all of them you have to transfer. So L elements were originally there that you are transferring on the right side, plus whatever you had transferred from the right as well. So n minus 1 minus r. So this will total be how much? This will total be L plus 2 times n minus 1 minus r. So this is what we can do. Let's try and code this up. I'm assuming that you have a bit of idea about two pointers and sliding window. Even if you don't, so it doesn't affect much, because you'll understand this while I'll write the code. So obviously I need to maintain a window. So I'll say that my L will stand at 0 and my R will also stand at 0 initially. Okay, and initially I'll say that my result, I'll keep it as int max. Basically initially I have to minimize my answer. So initially I'll take my resultant as maximum, And then I will also take unordered map. Okay, why I will take this map? Because it will help me to keep a track that if an element is occurring more than one time, so it is basically repeating and I need to move away from the left window. Okay, so what I can say here is that while the r is lesser than the size of the array, lesser than n, till that point of time we'll iterate and we'll say that we'll update the frequency of the rth element inside the map. So we'll increase the frequency of that guy. And then after this, what I will say is that while the left pointer is less than equal to the r pointer, and at the same time the element on the right currently, if its frequency becomes what, if its frequency becomes greater than 1, so then in that case it is occurring for more than one time in this window, so I need to move away from the left element. So what I'll do is I'll say that I'll decrease the frequency of the current left element from the map. Okay, and then after that I will move on my left index forward. Okay, this is what we will keep on doing, and you can say that result will be what, it will be the minimum of the result that I have stored so far, comma what, comma 2 into l plus n minus 1 minus r, as I have already explained, comma what, comma l plus 2 into r minus l, sorry, l plus 2 into n minus 1 minus r. Okay, so this I have already explained to all of you, and then after that you will move your r pointer forward. Okay, and at the end we can simply return our resultant variable here. So if you will see here, a time complexity will be basically order of n here, and space will be order of n because I'll be using a map as well. So let's try and compile and see. So it says that we are getting certain errors, so I guess I have made a spelling mistake. Okay, so let's try and compile it again and check if there's any other mistake in terms of syntax. It works fine on the samples. Let's try and submit this. It should get accepted. Let's see what happens. So you can see that my code was able to pass all the test cases. I hope that you have understood this problem clearly. If you have any doubts or any confusions, you can comment in the chat, and I'll reply to it as soon as possible. So let's discuss about the next problem, that is maximum inversions. It was the most interesting problem of the contest, and it is very easy if you understand greedy and prefix suffix based approaches, right? So let's discuss this problem. It says that you are given an integer array, and the array will be of length n, and it will consist of only three kind of elements. Okay, so the either the element can be 1, or the element can be 2, or the element can be 3, and you have to find out the maximum number of inversions in the array. If you are allowed to do what, if you are allowed to choose maximum one element of the array, so you can choose any element of the array, and either you can make it 1 or 2 or 3. Okay, so you are allowed to change one element of the array, and after that change you have to tell that what are the maximum number of inversions that you're getting. Now what is the definition of inversion? So basically, if you have two different indexes, let's say I and j, then one inversion is counted. If you have if you have two different indexes I and j, then one inversion is counted if the ith element is greater than the jth element, then it is counted as one inversion. So you can see in this particular scenario that if you are allowed to make one change, then what is the maximum number of inversions that you can get. So also one more thing, the criteria is that the I index should be lesser than j. So the element I should be on the left side and element j should be on the right side, and the ith element should be greater than the jth element. This is the definition for counting one inversion. So if you will see the sample test case, let's say if you have got the array as what, let's say you have got the array as 1 comma 2. Now if you have got the array as 1 comma 2, so you want to choose index I less than j and the ith element to be greater than the jth element, right? Right now you can see that it is not possible in this array. So what I can do is I can apply the concept that I can change one element as per my choice, because I am allowed to change maximum or at most one element. So if I make the element 1 as 3 now, and now the array will look like what, 3 comma 2. Now you can see that I have got one inversion, because if I have got this I index and this j index, so you can see that I is less than j and the element at the ith index is greater than the element at the jth index. So my final answer is what, the maximum number of inversions that I can have after conversion is basically 1, because earlier I could have 0 inversions, and after making the change now I can have one inversion here. Okay, so you can see that for the first test case we are getting the answer as 1. Now for the second test case, if you will observe, so let's say we have the array as what, let's say we have the array as 3 comma 2 comma 1 here. Now if we have got this particular array, so you can see that if I choose the element 3 with 2, then you can see that if I choose the element 3 and 2, so the element 3 is lying on the left side and it is greater than the element 2. So that's why you can count this as one inversion. Then another inversion will be 3 comma 1, another inversion will be what, 2 comma 1, right? So this element with this element, then 3 with 1, and then 2 with 1 also. So you can see that we have total 3 inversions, and the maximum answer you get is when the array is in descending order, because in this case every ith element is always greater than the element on the right side. So that's why you'll get the maximum number of inversions in this case, and you don't need to make any manipulations. So you can see that the maximum number of inversions here is 3. So how can we solve this particular problem? For solving this particular problem, first of all, what we can do is we can calculate the prefix count and the suffix count. Like, what do I mean by this? So first of all, we'll iterate from the right side to the left side of the array, and we'll keep on counting that whenever I am at a particular ith index, then how many elements are there. Whenever I am at the ith index, so how many elements are there on the right of the ith index that are 1 or that are 2 or that are 3. Because suppose if I am at a particular element which is nothing but 3, so if I am at a particular element which is 3, then I need to then the inversions will be what? If I am at a particular ith element, suppose, and that ith element is basically 3. Okay, if I'm at a ith element whose value is 3, so now all the elements that are either 2 or that are either 1, they will come, they can get counted, right? Because they will come under the inversion category now, because 3 can make pair with 2, 3 can make pair with 1, and like that. So basically my answer will get updated by the count of the total number of 2's that are there on the right side and the total number of 1's that are there on the right side. So that's how I can keep a track of my total number of inversions initially, and I can do this using the like suffix concept, basically, right? Then after that, I'll do the same thing for prefix as well, and then I'll try to manipulate that. If I change the ith element, so what is the difference or what is the impact that it is going to make? If it makes a bigger impact, then whatever difference is going to make the biggest impact, that I'll store, and at the end we can return the original number of inversions that we were getting, plus the inversion that I can get if I change any ith element. So we'll take that particular difference, which is maximum possible. So let's try and implement this code so that we can understand it better. So what we will be doing here is, first of all, if we have got this function, so firstly we will take one answer variable, let's say as long answer. Now when we take this answer variable, so initially we'll initialize it as nothing but 0 here. Then after this we can do what? We need to store for a particular ith index, we need to store the count of 1's, 2's and 3's. So that's why we can take a tuple here, okay, because we need to store a triplet basically. So we can declare a tuple, let's say vector of int comma int comma int, and let's name this as post count. Okay, so basically this will be counting from the ith index till the right side, okay, till the end part of the array. So initially I'll declare the array of size n here, right? Then after this, what we'll do is we'll declare another variable, let's say right count of 1. Okay, initially I'll mark it as 0. Then I also need right count of 2, initially I'll mark it as 0. Then I need right count of 3, initially I'll mark it as 0. Okay, then what we will do here is we'll iterate. So we'll say that int I will start from where? N minus 1 from the end. Then I is greater or equal to 0, I minus minus, because whenever I am at the ith index, so I'm checking that how many 1's are there on the right side, how many 2's are there on the right side, how many 3's are there on the right side. Okay, because I need to keep a track of the inversion. So I'll say that post count for post counts is basically the suffix count. For this particular ith index will be what? I'll make a tuple here. So let's say I'll use the function make tuple, and then I'll store the right count of 1, then right side count of 2, and then right side count of 3. So these are the things that I'll store. Now after that I'll check. Suppose if the ith element is equal to 1. Okay, if the ith element is equal to 1, then it will not impact anything in the inversion. So I'll only do right count of 1 plus plus. I only need to increment it. Okay. Otherwise, suppose that what happens is, else if my ith element is what? If it is equal to 2. So if my ith element is 2, then this element 2 can make can create inversion with the elements that are 1 on the right side. So that's why I will say that my answer plus will be equal to what? It will be equal to the right elements that are right ones. Okay, on the right side, whatever number of ones that are there, this element 2 can make pairs with them in order to make inversions. Okay, in order to be counted as inversions. And then I'll say that I'll do what, I'll count this element 2 also. Then else if the element is 3, so otherwise if the element is 3, so I can say that I'll count the element as 3, and then I'll say that this element 3 can make pairs with which kind of element? 3 can make inversion pairs with 1 as well as 2. So that's why what I'll do is I'll do answer plus is equal to what? Let's say answer plus is equal to RC1, the number of elements that are there on the right side that are 1, and the number of elements that are there on the right side that are 2, because I'll make pairs with them. Now once this is over, once I have iterated from right to left, now I need to iterate from left to right. So what I'll do is I'll mark the left count of 1 initially as 0, then I'll mark the left count of 2 initially as 0, then I'll mark the left count of 3 initially as 0, right? Once this is done, then I will now be storing the difference, okay, that when I'm going to change the element, so what is the difference that I'll have, what is the impact that I'll have. And for that impact I need to know how many elements are there that are 1, 2 or 3 on my left side, how many elements are there that are 1, 2 or 3 on my right side. So that's why my post array will help. And when I'm iterating from right to left, so I'll keep a track of the left count of 1, left count of 2 and left count of 3. So now initially my difference I'll mark it as 0, and then what I'll do is I'll say that we can start from I starts from 0 till I is lesser than n, then we can do I plus plus here. Okay, now once this is done, so what we will do is we'll store the we'll get the right count of 1, okay, right count of 2 from the and the right count of 3 from the tuple. So right count of 1, 2 and 3 from the tuple if we want to get, so we can use this tie function. Then what we can do is we can write the post count of I. Basically it will be equal to the post count of I. For the ith index, how many elements are there that are 1, that are 2, that are 3 from this index till the right side, that we have already stored in the post count of I, so we can directly use it. Now once this is done, then after this what we need to do, so after this we will say that if suppose that the ith element that I am at, if it is equal to 1, suppose that the ith element that I am at, if it is equal to 1, so if the element that I am at, if it is equal to 1, so in this particular case I'll say that suppose if I change this element to 2, then what will happen. So suppose that if I change this ith element, instead of 1, if I change it to 2, then what is the impact that I'll have. So let's try and write this. So the impact that I'll have on the right side is how much, if I change it to 2, then whatever number of ones that are there, okay, they will get counted in my inversion. And what is the impact that I'm going to have on the left side. So on the left side, whatever a number of 2's were already there, they will now not be making pairs any longer. So that's why I'll say that left count of 2 will be subtracted, okay, because if I am at the current element and it is 1, so now if I'm changing it to 2, so whatever elements, if I have changed the current element to 2, then whatever elements are there on the right side, they will start making an inversion pair with me, okay. So that's why my right answer will increase by RC, right count of 1, okay, the number of elements that are there on the right side that are 1. And now if I'm making this element instead of 1, if I'm making it as 2, then whatever elements were there that were 2 already on the left side, now they will not make any, they will not contribute to any inversion pairs. So that's why I'll say that whatever is the left count of 2, I need to subtract, okay. Then my difference will be what, difference will be maximum of the difference that I have stored so far, comma what, comma the left change plus the right change here, okay. Now similarly what I can do is instead of having this element as 2, I can make it as 3 also, right? So if I make this element as 3, then what is the change that I'll get? So on the right side, the change that I'll get, if I'm making this element as 3, then whatever elements are there that are on the right side that are 1 and 2, they will get counted in my inversion. So the right side answer will be increased by RC of 1 plus RC of what? Plus the RC of 2. Okay, this is how my right answer will increase. And on my left side, what is going to happen? So on my left side, I can say that if I'm making this element as nothing but 3, so in that case, if I am making this ith element as 3, then whatever answers I was getting because of the element 2 and 3 on the left side, they will get reduced. So then I can say that my left will be what? It will be nothing but LC of 2 plus LC of 3. These two parts getting subtracted, okay. Now my difference will be what? Difference will be basically maximum of the difference that I have attained, comma, left plus the right change, okay. This is what will happen here. Now once this is done, then I also need to say that I need to count this, since this element was 1, so I'll do LC 1 plus plus, Okay, now once this part is done, then I'll say that else if my ith element was what? Suppose if my ith element was equal to basically 2. If my ith element was 2 and if I'm planning it to change it to 1, then what will be the impact? Suppose if my element was 2 and I'm changing this guy to 1. If I change this guy to 1, then what will be the right change that I will get here? So let me do one thing. Let's declare, let's declare the variable here only. So let's say long right. Okay, so what will be the right change that is going to happen? So the right change, if I'm going to make this element, like if this element was 2 and I'm going to make it as 1, then whatever elements were 1 on the right side, I'll not be having inversions with them. So I'll reduce their count. So right RC1 will be subtracted. And then what will be the impact on the left side? So long, let's say left side. What is the impact of the left side? So on the left side, you can say that if this particular element is 2 and now I am trying to make this particular ith element as 1, right? So in that case, whatever elements are there that are 2 on my left side, they will start making a pair with it. So then I'll say that left count of 2, like whatever elements are there on the left side that are 2, they will start making a inversion pair with this particular element 1 that I'm changing, right? So that's why my left will get impacted like this. Now my difference will be what? It will be the maximum of the difference that I've seen, comma the right plus the left. Okay, now after this, another thing that I could have done is that if my ith element, I can change it to, let's say, 3. If I change it to 3, then what will happen? If it is initially 2 and if I change this guy to 3, then what is the impact that I'm going to have on the right side and the left side both? So if I change this element to 3, let's say, then in this particular case, if this element was 2 already and I change it to 3, then whatever elements are 2, okay, they will start contributing, because if I change this particular element to 3, then whichever elements are 2, they will start making an inversion pair. So I will have this counter. Okay, then after that I can say that on the left side, what will be the change? So on the left side, if I make this element as 3, then on the left side I will start having problems, right? On the left side, whatever 3s were there, they should be removed, because if this element was basically 2 earlier, okay, so it must have made inversions, which whatever elements were there that were 3 on my left side. So now it will no longer be able to make it. So that's why my left will get subtracted by this much, and then I'll say that the difference is what? The difference is max of the difference, comma the right plus the left impact. Okay, now other cases that if this ith element is 3 and I'm changing it to either 1 or 2. Okay, so suppose that else, in the else case, if my ith element is basically equal to 3, then what if I change this ith element to, let's say, 1? If I change this ith element to 1, then what is the change on my right? So I'll say that long, the right change will be how much? If I change this element to 1, okay, then if this element was 3 and I change it to 1, then on the right, if the element was 3, then it must have made pairs with the elements that were 1 and 2. So now those pairs will no longer be available. So you will see that RC of 1 and RC of 2, the elements that are there on the right side that are 1 and 2, they will not be able to make any pairs further. So you will subtract those elements. And also one more thing I forgot, that in the else if case, I should do left count of 2 plus plus as well. Okay, and here also I'll just do the same, left count of 3 plus plus before we proceed further, right? Now after this, I'll say that the left change that is going to happen is what? If I make this element as 1, okay, if I'm making this particular ith element as 1, then whatever elements are there that are 2 and 3 on my left side, they are going to make a pair with me. So then my answer will increase by what? Like I'll say that left count of 1 plus the left count of, sorry, if I'm going to make this element as 1, yeah, so then left count of 2 plus left count of 3, because this ith element will start making inversions with the elements that are 3 and 2 on the left side. Okay, then I'll say that the difference will be what? Difference will be maximum of the difference, comma the right change plus the left change here, guys. Okay, now what is the other scenario that I can imagine? That if this element is there and I make this ith element as, let's say, 2. Okay, so if I make this element as 2, then what is going to happen? Suppose if I make this particular element as 2, then in that case I'll say that long, my right change will be what? If I make this element as 2, then whatever elements were there on the right side that were 1, they will stop making a pair with me. Suppose if I make this element as 2, okay, so whatever elements were 1, they will still make a pair with me, because with respect to 2, the elements 1 can make inversions. But now if this element was originally 3, so 3 was making pair with 2 and 1. Now if I change it to 2, so 2 cannot make inversion pair with 2. So that's why on the right side the impact will be RC of 2. So whatever elements were there on the right side that were 2, now they will not make any pair with me, okay, any inversions, right? So then the on the then after that, on the left side, what is going to be the change? So let me just do one thing, let me remove this declaration again, okay. Then on the left side, what will be the change? If I make this element as 2, then whatever elements are there on my left side that are 3, they will make a pair with me. So I'll say that my answer will be the left impact will be LC of 3. Then after that, the difference will be what? It will be the maximum of the difference comma the right plus the left here, okay. Now once this is done, then at the end of the day, we can do what? We can return basically the answer plus the difference plus the additional like after the additional change, like after changing one of the elements, either 1, 2 or 3, any element, making a change at only one index, whatever is the maximum possible difference that I could make, that I will add, okay. Now let's try and compile this code to check if it is working fine or not. You can see that the time and the space complexity are order of one, sorry, order of n basically, yeah. So I'm not getting the exact answer that was expected from me here. So let's check what can be the issue here. So I might have made a certain mistake. Let's quickly iterate through and check if there is any mistake anywhere. So what I've done here is, first of all, I have declared one answer variable, then I have post as well. When my right count, initially the counters are 0, then I'm making a tuple. So that also seems fine. Then if the ith element is 1, then I'm increasing the ones. If it is 2, then inside my answer I'm updating with right count of 1. Okay, I have done plus plus here. So that is one mistake. Right count of 1 plus plus was the mistake. Okay, now let's try and compile this again to check if it is working fine or not. Okay, it works fine now. So basically I had done one like typing mistake. Now let's try and submit. It should get accepted, and I hope that you have understood the ideology of this problem. Okay, so it doesn't get accepted for the sample test case. My code's output is 0 and the expected output is 1. Okay, so let's check if there is any other mistake anywhere, because I have explained a lot, so I might have made any mistake. So let's see. So I have done what here, like if the ith element suppose was 2, okay, if the ith element was 2, then the answer was updated by 1, then I'm doing right count of 2 plus plus. Otherwise I'm doing what? Right count of 3 incrementing if it is 3, and then the inversions will be right count of 2 plus right count of 1, okay. Otherwise I'm initially making the counter of lc1 lc2 lc3 as 0, and initially I'm taking the difference initially as 0, then I'm trying to get the R1, RC1, RC2 and RC3 using the post count of I, which is already stored. Then after this, if the ith element suppose was 1, then what have I done? So if the ith element was 1, if I change it to 2, then that will be nothing but RC of 1, and left change will be minus LC of 2. Then the difference will be max of the difference from a left right. Then if I change it to 3, then it will be RC of 1 plus RC of 2 and minus LC of 2 plus LC of 3. So that this also seems fine. Yeah, so I've done different minus is equal to difference is equal to is what I should do. So another typing mistake was there. Let's try and see if it gets compiled. Now it will obviously get compiled. Let's try and see if it gets submitted or not. Okay, the output is processing. Let's see. So you can see that my code was able to pass all the test cases. I hope that you have understood the use case, and main thing is the ideology. If you understood the idea, like how to think about such kind of problem, because see, whenever you see this kind of problem in a contest, if you are not able to if you are not able to solve it today, now you have seen the solution. Now you have seen me approaching this problem. So I hope that you have understood it clearly. Please make sure to comment understood or clear or +1 in the chat if you understood it clearly, because it did took a lot of effort to explain this while writing the code, and I did not want to do any dry run, because it's not based on dry run, it's basically based on the concept part. Okay, so regarding dry run, main thing is that dry run is not that required if you understand the mathematics behind it. So I hope you have understood it clearly. Please make sure to comment understood or thank you in the chat, and keep coding guys, and keep doing GFG. Thank you.